I'm Pat Dugas. Today we're going to look at infinite geometric series, that is a series that go on forever. We're going to look at finding their sums and determining whether they converge on a single number or they diverge. Let's look at the convergence or divergence of the series first. If that common ratio r, and we're talking about the absolute value of that number, is less than 1, then the series will converge on a fixed number. For example, the series 5, 2.5, 1.25, its r is 1/2 each time. We're multiplying by 1/2, and the absolute value of 1/2 is less than 1, so this is a series that converges on a finite value. Its sum converges. If, however, the absolute value of that common ratio is greater than or equal to 1, then the geometric sum is going to approach infinity. It's never going to reach a finite value. So for example, this 1/16, 1/8, 1/4, it is actually getting multiplied by 2 each time. 1/8 divided by 1/16 is 2, 1/4 divided by 1/8 is 2. It's getting multiplied by 2 each time. It is never going to approach a finite value. So the way to test it is strictly looking at that r value. So let's look at a couple of examples here and determine whether they're converging, their sum is converging on a finite number or it is not. In other words, it is divergent. Determine whether the infinite geometric series given below is convergent or divergent. So we've got 729, 243, 81. So we've got to find that common ratio r. R is going to be 243 divided by 729. Any of the second terms divided by their previous terms, and this is in fact 1/3. So since r is 1/3 and that is less than 1, the absolute value of that is less than 1, it converges. This second series, we're going to determine whether it's convergent or divergent. We've got 2, 5, 12.5. Well, 5 divided by 2 is equal to 2.5. So the common ratio is 2.5. The absolute value of 2.5 is greater than 1. Therefore, the series diverges. So we've talked around the idea of the sum of an infinite geometric series. Let's actually look at calculating it. The sum of an infinite geometric series is equal to a sub 1, the first term, divided by 1 minus r, the common ratio. Very simple formula. It is related to the sum of a partial geometric series. You might recall that was the sum of the first n terms is equal to a1 minus a1 times r to the n over 1 minus r. So let's go ahead and calculate some. So let's look at some examples. Find the sum of a 3, -3/2, 3/4, -3/8 if it exists. So first we've got to find that common ratio r, and that's going to be equal to a sub 2, -3/2, divided by 3. So when we divide -3/2 by 3, we get -1/2. Each time the term is being multiplied by -1/2 to get to the next term. And so since the absolute value of -1/2 is less than 1, this converges. So it is going to have a sum that it converges to. Let's find that. By the way, this is called an alternating series if it alternates from positive to negative. So let's look at the sum formula. It's a sub 1 divided by 1 minus r. So a sub 1, our first term, is 3. Our common ratio is -1/2. So it's 3 divided by 1 minus -1/2. So our total sum of the infinite geometric series here is 3 divided by 1 minus -1/2, which is 3/2. So that's going to be the same as 3 times the reciprocal of 3/2, 2/3, which is going to be 2. So the sum of all the infinite number of terms in this is actually 2. Let's look at the second example, another alternating series between positive and negative. -4/3, 4, -12, 36, -108. Now I can look at any two terms here. I may as well pick something a little bit easier to work with. Let's look at these two terms. So to find r, it's going to be negative 12 over 4. So negative 12 over 4 is negative 3. The absolute value of negative 3 is 3, and that is greater than 1. So this series diverges. Therefore, it is not going to have a sum. It is going to go off into it. Its sum is going to go into infinity. Let's look at the final example here. We've got the sum of 1, comma, 1/2, comma, 1/4, comma, dot, dot, dot. Let's look at the common ratio, r, and that's going to be 1/2 divided by 1, which is 1/2. Each time this is being multiplied by 1/2. Absolute value of 1/2 is definitely less than 1, so it's convergent. It is converging, and so it's definitely going to have a sum. The sum is equal to a1, a sub 1, over 1 minus r. A sub 1 in this case is 1, and r is 1/2, so it's 1 divided by 1 minus 1/2, or 1 over 1/2, and that's the same as multiplying 1 times the reciprocal of 1/2, 2 over 1. This series also converges. Its sum is 2, just like part A. So we've taken an introductory look into geometric series that are infinite, whose terms go on forever, and they either converge or diverge depending on their common ratio, and we found their sums as well.